Hello, good morning everyone. I am Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I am going to explain about the digital modulation techniques. We have various digital modulation techniques. In this video lecture series, specifically I am going to explain about the quadrature amplitude modulation, where quadrature amplitude modulation is nothing but a form of modulation which is widely used for modulating data signals onto a carrier which is used for radio communications, where QAM is a signal in which two carriers shifted in phase by 90 degrees and are modulated. The resultant output here consists of both amplitude and the phase variations. Hence, it may also be considered as a mixture of amplitude and a phase modulation. Why we are going for quadrature amplitude modulation is it mainly saves the bandwidth. And how? By using double sideband suppressed carrier. That is, by using double sideband carriers, the bandwidth will be twice that of the other signal. This is very wasteful for the available frequency spectrum, and it is also. Then this QAM places two independent double-sided suppressed carrier signals in the same spectrum as one ordinary double sideband suppressed carrier signal. The various types of QAM are where it exists both in analog and the digital formats. The analog versions mainly used to allow multiple analog signals to be carried on a single carrier. It combines phase modulation and amplitude modulation in the form of modulation, on where it is called as a quadrature amplitude modulation, where digital formats of this QAM are often referred to as a quantized quadrature amplitude modulation. It combines both phase shift keying and amplitude shift keying in a form of modulation known as the quadrature amplitude modulation. Yes, QAM is nothing but it states both amplitude and phase change with the QAM signal. This will generate a signal that is the sum of both waves, which has a certain amplitude resulting from the sum of both signals and phase, which is again independent upon the sum of the signals. Vacuum here, it consists of two RF carrier signals that can be modulated. These are referred to as a in-phase quadrature amplitude signal and in-phase and the quadrature phase signals. The in-phase and the quadrature signals are here represented as a cos pi, and q is nothing but a cos I. It can be seen that I and q components are represented as a cosine and sine. This is because the two signals are 90 degree out of phase with one another, where QAM has a modulator and a demodulator. Here modulator, it consists of where the input signal is given to the mixture, it mixes the oscillator signal. Oscillator here mainly uses the frequency range of signal, where the mixer and the oscillator signals are combined and it is given to the output, and also from the signal here takes a 90 degree phase shift of the signal, where the 90 degree phase shift and the oscillator frequency signal combines and will get a output in the quadrature amplitude modulator. The two resultant signals, where we have in inputs two signals, so the two resultant signals are summed and then processed as required in the RF signal chain, typically converting them in frequency to the required final frequency and amplifying them as required. If in case of any non-linearities, it will alter the relative levels of the signals and alter the phase difference, where it thereby distorts the signal and introduce the possibility of the data errors. The next is the QAM demodulator. It is very reverse to that of the QAM modulator. Here the signals enter the system, they are split in each side and it is applied to the mixture, where in modulator the signal is combined. In demodulator the signals are separated. One half has in phase local oscillator applied, whereas the other half is in quadrature oscillator signal applied. One half is in phase, next one is in quadrature phase. This is what about the quadrature, amplitude modulation and demodulation. Then by using the constellation diagram, we'll see the states how it differs from one position to the another position. So as the order of the modulation increases, the number of points on the QM constellation diagram. The main advantage is that it is the higher order form of a modulation, and also the data rate in this link can be increased. Then the bandwidth efficiency has twice that of the other frequency components. Here the bandwidth is twice that of the signal. And the main disadvantages is that it contains an amplitude component where the linearity here must be maintained. Where the linear amplifiers here are less sufficient, so it consumes more power, and also it makes them less attractive for mobile communications. Applications: this is used in ADSL technology for twisting copper pairs, and also it has ultra high capacity microwave Hall system which uses 1024 qm, and this quadrature multiplexing is used in color television in order to multiplex the so-called chrominensis signals which carry the information about the colors. Thank you.